Hi guys, welcome to Learn Electronics Repair. I have something very large on my desk today, and I'm sure you'll be interested to know what's inside it. Let me get you the camera, we can have a quick look around. So here we are with shaky cam. You can see power amplifier, Myson biamp, 1000 watts, large flight case, which I think we can actually open. Okay. Both sides. Let's see what's inside. And in here we have this Newmark D2 director. MP3 I would think, doesn't look like it's CD or anything. Okay, big mixer there, and he says that the mixer Soundcraft EFX8, one of these two sliders doesn't work or makes strange noises. Okay, so that's a problem with the mixer. And he says that the fan, or one of the fans in the amplifier, isn't working. This whole thing actually angles out like so. Yeah, like so. Yeah, so that's how this would actually be used. No doubt this is off one of the Carrozza. In fact, the guy owns a Carrozza. So yeah, that's what it will be. For those of you, and I know a lot of you now do know what a Carrozza is, here quickly on screen is a Carrozza. Just out of interest, by the way, I asked this guy, and if he stands by his word, or we have time, he says he's actually rebuilding his around January, February, ready for the carnival season, starts in March. So yeah, I asked him, can we go and actually have a look, you know, how it all works, how the power is generated, the whole sound system, the lighting system. He said yeah, so we're going to make a video about that. But for now, let's see if we can fix this. You can see a few leads and power supplies in the back of here. There's the amplifier, so one of the fans not working. The most obvious thing to do here is to remove the mixer and the amplifier from the flight case, and then I can work on them. The actual DJ player there, that is working. Okay, so amplifier first. Just comment, by the way, that unit was like from a modified flight case. Somebody actually made that out of a flight case. I think they did a pretty good job of it, I have to say. A bit of mechanical ingenuity there. So this, he says one of the fans isn't working. So there are fans in here, which even have blades. Yeah. Do you remember the one that didn't? All the blades are sheared off. Yeah. So they rotate clearly or easily enough. Right, so first of all, let's just power this up without any speakers. I want to see if these fans are ones that run all the time, or are they ones which are activated by temperature. I pretty much trust this customer, so I'm actually just going to power this up without the current limiter on. We hear fan. Okay. And he's correct, only one fan working, but that one isn't stuck, so let's have a look. Okay, so this is the one that works. What voltage are these? They're probably 24 volt, maybe 12 volt. Let's have a look. Could be 240 volt. 12 volt, okay. They have different brand stickers on, which makes me think that one's been changed previously, but it is another 12 volt, okay. So yeah, that's what goes over here. This one's got a bit of tape holding it together or something there. And they both disappear down in that direction and onto this little board here. Okay. This is the PCB. It has a couple of relays on here. A few transistors, and then you can see here, this is the connection to the fan, red, black, but they both connect to the same place on the board, so it's not going to be that there isn't power getting to one but there is to the other, unless there's a problem with the actual soldering onto the wire. Okay, we can see the wires there, the two red ones, the two black ones. So it's looking like a possibly faulty fan, even though it spins, yeah, or some other connection problem to the fan. Let's just remove these cable ties. I could feed the wire back through, but I have plenty of them, so no problem replacing them. Red one goes to the outside edge. But you never know. You see, if I end up having to order a fan, by the time it arrives I won't remember. So if I put a B on this side, I don't need to put an R on the other side, because by default, yeah. Yeah, there's like a little tag on there basically. Okay, well in this case we'll leave the tag in there on this one. Yeah, well, I should have done the same with this one actually, because I need to unsolder the wires to separate them anyway. Okay, so I can easily test these now. 12-volt power supply. This one's working. This one doesn't work. Okay. So in ohms range, this is the one that works. Actually reads like very high, 100 kilo ohms. This one. Higher. Let's try diode mode, so black to the black. Reads like 1.6 volts drop all the way around. Reads open. How about the other one? So there is like a diode effectively there. That means lower all the way around. Also reads like a diode both ways, so let's get this out. I say like a diode, it's 1.3, it's higher than a diode, but it has a reading both ways. Of course, you can't get the fan out without taking the amplifier PCB off, yeah? What do you expect? Well, they don't make this easy, of course, do they? So, it is off now. There's two LEDs here, which actually stick into two little holes on the front. These are limit LEDs, something like that. And you, it's just so difficult, yeah, that's all I'll say, because there's not enough space, but eventually I got it enough to get this thing out. Okay, so what's with the fan? So here is our fan. This order the 1R replacement. Model number 12 volts, 2.6 watts. I found that fans and amplifiers tend to push more air basically than typical ones found in PC cases or ATX power supply, so they can be a bit difficult to replace. I mean, probably the only option is to replace it, but while we're here, let's have a look. I'm interested to see, there's obviously some circuitry in here. Can we even get to the part? It's not a mechanical problem from what I can see. Is it just a bad connection somewhere? But it reads different. It doesn't read open, so I don't think it's a broken wire. I'll just connect it again to my bench power supply. And it moved and stopped. See that? And it's drawing about half an amp, actually. Like a little plastic thing there. Often you can't get these things apart. There's a little, like you see there, it's like a split ring, circlip maybe. I mean, the fact it says it's 2.6 watts. Well, watts equals voltage times current. So voltage divided by current would give us watts. Yeah. So 12 divided by about half an amp. Just over. So that's a good 6 watts. It's over what it should be. Yeah. Well, I've got the circlip thing off. Getting it back on might be another matter, but it's off. No, in fact it broke. Yeah, I thought it might. Oh well. And it actually broke while I was trying to get it out. I couldn't get this to release. Okay, so what you have on here basically are a couple of windings, you can see that. And these will be MOSFETs or transistors. And this oscillates, it's an oscillator effect. When it runs at quite high frequency, that's what drives the coil, which is what causes the fan to spin. Another transistor there. This looks like a diode. Okay, some corrosion here, typical corrosion. This is probably some sort of positional sensor, or so. It knows as the thing is going and it's sending pulses, something like that. Yeah. So they're quite interesting little things, really. I don't suppose we can find out what these things are, but we could have a go just out of interest. Or we could just use the meter and see what they look like. Obviously I need a new fan, but you know, interest. Bear in mind this one was faulty, it read faulty, we could see that. So here's a diode, is this? Reads like a diode that way. Has a reading that way also. Reads like a transistor. That reads like an NPN transistor. The other one was the same marking. Okay, so out of interest, they look like NPN transistors. Let's take a photo of one of these and ask ChatGPT what it thinks it is. Can you identify this SMD component? It measures like an NPN transistor in circuit, and there's quite a clear photo. Let's see what we get. Well, it knows it's marked DF and RD. I didn't tell it that. SOT89, DF means 2SD1898, general purpose NPN transistor, and other possibilities, MOSFETs and other things, but we know it measures like a transistor, so it looks like this is the answer. If it truly reads DF on one line and RD on the next, it could simply be two separate codes. However, it seems especially likely these ones because they are indeed NPN transistors and they're common. Yeah, okay, an SOT89 package. They fit your assessment, and I'll say yes, DF and RD on separate lines. And it's found another image of it, confirmed, okay, and it knows what it is, it's that thing. There's another option, but that's PNP, so we know, and it's also SOT23, which is a smaller transistor, so we know what it is. And the same would apply with this transistor 1P, that is an SOT23 package, so we could tell it that. This reads like a diode or Zener diode, I'm pretty sure that's fine. This thing, I'm not sure what the action is. Seeing as we're here, why not Luke? That is not marked actually, so, well, yeah, maybe something on the back of it. Wouldn't be surprised, that's some sort of Hall effect sensor or something like that, and probably not the sort of thing that would fail. Yeah, that's what I'm guessing. Actually, this is interesting enough to try and figure it out, I think. So, we have red wire. The black wires fell off, by the way. But it was here. Another resistor under there. So this is the junction between the two wires, or it's supposed to be. That seems to have gone. This is plastic. Okay. These are your two windings, the different colours, and you can see that one of them goes off over that way, and the other one I think disappears down under there and comes back round the other way and comes out here. Yeah, you can see the end of that one coming out here in the opposite direction to this point, which should be joined together, okay, and possibly go to one of these terminals. A bit hard to say now. So if you look at this is also gone here. So if we measure from here, you can see where the track goes over here to this. And that is open circuit. We have a connection as far as here, so it's gone there, okay. This device looks like a transistor. Let's test it. So yeah, diode junction with the red to the base. So we have an NPN transistor here. This is the cathode, so that's driving the base of that one from the collector, and from the emitter is driving the base of this one. You can see the track goes around the edge to here, okay. The collector of this drives one of the coils, that one. And the collector of this, well, they've used that pin because that pin and that pin are the same thing. And the collector of that one, yeah, goes to here. In fact, this one drives that coil and that one drives the other coil, okay. You can see it there where it goes into here. Again, it's gone open. It's blown. So something's blown this thing, basically. But these two transistors should drive the two coils in opposite directions. One of them will switch on when the collector of this is high. So effectively when you switch this transistor on, you will pull the voltage here down via a diode, admittedly. The base voltage of that one is connected to the emitter, so there'll be a voltage on the emitter when this transistor is switched on. So it seems, without actually drawing the schematic, that depending on whether this transistor is on or off, either that transistor will be switched on or this transistor will be switched on. And they won't be both switched on at the same time, they'll be alternate, yeah. I'm pretty confident that would have gone to ground. Or 12 volts, and the other end of these emitters of these two may go to ground. They go off under that way somewhere. They go to this device. So I would say, if you look, this is like metal, I think it is. Yeah, other wires fell off now, of course. So this is like a magnetic core, and this is sensing this. So this Hall effect device or some sort of magnetic sensor will be sensing the direction of the current in the winding. And I would say, because a winding is an inductor, okay, so when you first apply the voltage, the current doesn't flow, okay. In inductors, voltage leads current, okay. So you power up the coil, yeah. After some finite but short amount of time, the magnetic field will build up. This will detect it. This then will switch this transistor, which switches one of these off, the other one on. You power up the other coil, so it demagnetizes, magnetizes in the opposite direction. This will detect it again, switches the transistor the other way because the field's going the other way, I'm guessing. So basically, how this is oscillating, because there's no capacitors in this circuit to charge, is using the charge of the motor winding, effectively the magnetic charge. And as it increases magnetism in one direction or the other, it switches this transistor either on or off, and that switches either of these on, which then puts the current back in the coil the other way around, and so on. I think that's how that works. I mean, yeah, you've got a very close image if you want to really try and reverse engineer that, but I don't think I do need to. I think that is a very good understanding of how that thing works. Actually, this makes a lot of sense if this is a Zener diode. So we know this is the cathode. It reads about 0.68, 0.69, which is a bit like a Zener, to be honest. And if it's a Zener, then the base of this transistor would only have drive, yeah, be turned on, if the voltage here on the collector exceeds the Zener voltage plus the base emitter voltage there, okay? And because the collector is driven via a resistor, 2K from the 12 volts, when the transistor switches on, the voltage here will drop. If it drops below the Zener voltage, that will switch off. Obviously, the voltage on the emitter will go up, and if it's above the base voltage, that will switch on. So that makes perfect sense, yeah? Who needs schematics? This is all a moot point because we need to get another fan. Let me see if I can find something that really is directly compatible with this one. Okay, so I've had a look on AliExpress. That's actually the exact model number of the fan I have. Admittedly, one of the two has already been changed, but I don't know which one of the two. The label on this looks quite old, so maybe this was the original. There are also some with very similar numbers on here. If we look, for example, for Sunon 12 volt 2.6 watt fan, yeah, but with different numbers, and I wouldn't be surprised, maybe we could look it up, but these numbers are related to the airflow and other characteristics of the fan. So I'm going to put the exact replacement in. These are not cheap, you can see that. Hey, well, the customer's paying, and at least I'm confident that the fan will operate as intended. And bear in mind, this thing probably came off the Carrozza or float. Yeah, so these are used outdoors in high ambient temperatures, and they have a very hard life. So yeah, I'd rather fit that. I mean, I accept I could take an ATX power supply or something similar, PC fans, 80 by 80 millimeters, or even 80 by 80 by 25 common, and effectively get one for nothing and stick that in there. But you know what? I think I've learned a little bit from experience. I'm going to put this thing in, yeah, the proper one. I'd be very interested to know what you guys would do though. Chat about it down there. Next, we'll look at the mixer. I'll probably end up ordering parts for that as well. Slider. He did mention, I think, he had a scrap on him out of the parts for that. So let me have a look to see what was actually causing the problem, if it is the slider first. Okay, and the mixer, well, I can't find anything wrong with this. Slider works fine. Slider works fine. Yeah. Just don't see a problem with this. Okay. So I've recorded a bit of this, showing the guy, sent it to the guy, told him we're waiting for a fan, the correct one. As far as I can see, this works. Okay, so, yep, can't do anything with the mixer other than that. Let's see what he says. Okay, so both fixed in one video. Hope you enjoyed that. Let me know down there what you think. I'd be interested to know what you think about the fan replacement. Would you actually use the original type, which I've done? Yes, it's a bit more expensive. Or would you, as I did, comment, take something off a PC or an ATX power supply and stick that in? Well, I've told him we get an original, but anyway, tell me what you think down there, and I look forward to seeing you all soon again on Learning Electronics Repair.